Okay, these are some of the proofs from section 4.4, and it really takes a lot of time just to draw your sketches, so you can do all that ahead of time, as I suggested, I think, on the website. And you draw your sketch, what you want to prove, you draw your horizontal line and your vertical line, statement, reasons, numbers. When you have all this stuff done, the rest is easy, except on these first two, there was a little intermediate step that we had to go through to see what we had, because they gave you this information. I put it in pencil because it's just what we need to determine the parts that we're going to use for our proof, and that GH is 3 and HI is 3x minus 9, but x is 4. So if I put 4 in here, what's 3 times 4? 3 times 4 is 12. 12 minus 9 is 3. So these two segments are congruent, so we would just put a mark there and there and say that that was given. So you'd say given that HG is congruent to HI. So that's what I wanted you to do, was just use that value of x. We also have that since x is 4, this side is 2x minus 3 and this side is 5, but 2 times 4 is 8. 8 minus 3 is 5. So that means that these two segments are congruent. So that's basically all we wanted to do. So we would mark that with 2 marks. We can put that down as our second given. The GJ is congruent to IJ. All right. So those are our two actual givens. Okay. And then we'll just put this into our proof, and we want to prove that these two triangles, and always have to watch out for the correspondence, GHJ is congruent to IHJ. Okay? So again, my statements, I'm going to use my two givens. I can start with HG is congruent to HI, and that's a given. And then GJ is congruent to IJ, and that's also given. All right, so if you have that written down, that saves you a little bit of time. Just fill that in. And if we look at our triangles, we have two ways to prove triangles are congruent: side, 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 side angle, side. So I'm going to probably go with side, 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 because I have a side here and a side there. And I just need one more side. Okay. Remember, we've talked about this before. If we look at these, we've got two triangles, but if you look at this triangle, GHJ, and the other triangle, IHJ, HJ is in both, so that's our common side. So we can just say it's congruent to itself by the reflexive property. That's one we use a lot. We could put 3 little marks there, and we would say that HJ is congruent to HJ by the reflexive property of congruence. Reflexive property of congruence. You could abbreviate that a little bit more if you wanted. Okay? And then if I look over there and I see that that's another side, I've got side, side, side. Okay? So now I've got my triangles congruent. What I want to try to prove, triangle GHJ is congruent to triangle IHJ, and the reason is side, side, side. Okay, not too hard. Okay, and let's take a look at number 6. And number 6, we have this sketch over here. So I drew my sketch and set up everything so I would have a little bit of time. Remember, if I'm going too fast, you can always just pause it. Pause your video and take things down. So I already drew my sketch, my statement, reasons, all that's what I want to prove. And again, what we have over here is that x is 18. They tell me that x is 18. You can see all this over here. X is 18, and this is 61, and this is 4x minus 11. Well, 4 times 18, 18 and 18 is 36, and 36 and 36 is 72. 72 minus 11 is what? 72 minus 11 is 71, 61. So in reality, that just tells us that these two sides are congruent. Okay? So I could say that RS is indeed congruent to TU. And I want to keep my correspondence the same that's in my triangles. You don't have to, but it's kind of neat to do it like that. RS and TU are congruent. I mark those. And then I also know that if x is 18, what's 2 times 18? 2 times 18 is 36. So these two angles are congruent. So I can mark those with an arc. I could say that angle SRT is congruent to angle, so that'd be SRT and UTR. SRT, UTR. Notice how the correspondence is the same. Okay, SRT, SRT, UTR. So you get used to writing those correspondences the same because that's going to be important a little bit later. So that's what we've got. I've marked those. Now we have two ways to prove triangles congruent, side, 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 or side, angle, side. Well, since I have a side and an angle, it looks like I'm probably going to go side, angle, side for my strategy. So what I'll do is I'll write down what I have given so far. RS is congruent to TU, and that was a given. I guess I should do that in blue. And that's given. And then you also have that angle SRT is congruent to angle UTR. That's also given. And if I kind of list what I've got a side here, so I'll put a little S there for a side, and I've got an angle. So it looks like I got side, angle, and what do I need? I need one more side. And I notice that these triangles, like in number 5, they share a common side. RT is in this triangle. TUR, and RT is also in this triangle, RST. So since RT is in both, I can use it as a common side, and I can use that nice reflexive property. So I'll put 2 little marks there. And I'll say that RT is congruent to itself. RT is congruent to RT. Why? That's the reflexive property. I'll just abbreviate there a little bit more this time. Reflex property of congruence, and that's the other side. So now these two triangles are congruent by side, angle, side. So triangle, what I want to state, proof, RST is congruent to triangle TUR by side, angle, side. Okay? So I hope that makes sense.